Hi everyone. In this video we shall see the topics of the subject Quantitative Techniques for Decision Making. Unit 1 Introduction to Linear Programming. First let us see what is linear programming. The linear programming method is applicable in problems characterized by the presence of decision variables. The objective function and the constraints can be expressed as linear functions of the decision variables. The decision variables represent quantitatives that are in some sense controllable inputs to the system being modeled. An objective function represents some principal objective criterion or goal that measures the effectiveness of the system, such as maximizing profits or productivity or minimizing the cost or consumption. The important features of linear programming model is the presence of linearity in the problem. We have different methods to solve the linear programming problem. In this video lecture, let us see the graphical method. Graphical method in linear programming can be used to solve the problems having two decision variables. Let us see the procedure for graphical method. As a graph has two axes, select one axis each to represent one decision variable. The constraints are represented as straight lines on the graph, each constraint being represented by one line. First, we consider only the equation by ignoring the inequalities. Next, join the points on the x-axis and y-axis by straight line. This straight line represents the equation portion of the first constraint. The greater than or equal to or less than or equal to symbol in the constraint represents a line and a region to one side of this line. We determine this region by taking the values of either x or y, which is less than or greater than or equal to the point on the x or y axis. For example, if x plus y is less than or equal to 4, then we first draw the straight line x plus y equal to 4. Then say on which side of this line do the values of x or y less than 4 occur. That side indicates the feasible region. In similar manner, draw straight lines to represent other constraints. Then the feasible region is the region common to all the constraints. Next, identify all the corner points of this feasible region and name them as A, B, C, etc. Then we find the coordinates of all these corners. Now, substitute the values of x, y at each corner in the objective function z. This would give you the value of the objective function at each corner. Depending on whether the problem is maximization type or minimization type, select the best optimal value as a solution of the problem. Now let us solve a problem using graphical method by using the above procedure. Here the problem is solve the following LPP by graphical method. Maximize the function z equal to 5x1 plus 3x2 and the constraints are 2x1 plus x2 less than or equal to 1000, x1 less than or equal to 400, x1 less than or equal to 700 and x1 x2 greater than or equal to 0. The first constraint is 2x1 plus x2 less than or equal to 1000. Now just we consider only the equality, that is 2x1 plus x2 equal to 1000. Substitute x1 equal to 0 in the above constraint and we get the value of x2 as 1000. Similarly, give x2 equal to 0 and we obtain the value of x1 as 500. Now we have obtained 2 points using the first constraint. Next, for that corresponding constraint, just we draw the straight line using the two determined points and depending on the inequality whether it's less than or equal to or greater than or equal to, we have to find the feasible region. Similarly, we have one more constraint x1 less than or equal to 400. So by considering equality, we have x1 equal to 400 and that is parallel to the x2 axis. Similarly, the remaining constraints are plotted and the feasible region has been determined. Now, just for all the corresponding corners of the feasible region, we are finding the z value. Since the problem is maximization, the maximum value for the corresponding points, that is z equal to 2850 is the maximum value, where the corresponding Values are x1 equal to 150 and x2 equal to 700. Thus, the optimum solution has been obtained. Thank you.